Hi there, Mr. Holcomb here with a continuation of an episode of the Math Behind the Modules. Okay, this is Lesson 6, Part 2. I didn't want to make a video 40 or 50 minutes long, and we got to example 3 here, and I decided to stop the video and start fresh with the second one. Okay, so this has to write an expression in standard form. Standard form means to simplify it all the way as much as possible, but to the point where we can't combine anything else because they aren't like terms. So the first thing I'm going to do in this is going to get rid of these mixed fractions to make them all improper. So 3 times 5 is 15, plus 1 is 16, divided by 3. Minus 3 times 3 is 9, plus 1 is 10, divided by 3. Parentheses, 1/2 x minus 1. Okay, so the first step was just getting these to be improper. That's all I did. Step 2, I'm going to distribute this negative 10/3 to both of these terms here. This is just going to come down, nothing to do with it at the moment. And whenever you're distributing a number out in front, you have to pay very special attention to what the signs are. So a negative, and think of this as a positive. Negative times a positive is negative. 10 times 1, I'm not going to leave that plus sign there, so I'm adding, multiplying. 10 times 1 is 10. 3 times 2 is 6x. A negative times a negative is a positive. Always do that first so you don't forget, or your answer will be wrong every time. 10 times 1 is 10. 3 times 4 is 12. Okay? So I have a 3, I have a 6, I have a 12. I have a 10 here, which 3 won't go into, so I want to find a common denominator. But before I worry about that, let's get our like terms together. This is a constant, and this is a constant. So I'm going to write negative 10/6 x. Bring this out in front, and I'm just going to rearrange this because addition is commutative. So now I can bring that out in front, and this is a positive, or plus 16/3 plus 10/12. And then once I do this, I have to have a common denominator. So I don't have to change anything here because it's not a like term. I've got to focus on these two. Okay, I've got to get the same denominator so that I can add those. So I'm going to change this 3 to a 12. And to get that to be 12, I have to multiply it by 4. And 16 times 4 is 64. Plus 10 12. Okay, so negative 10 over 6x plus 74 over 12. Okay, I'm going to just reduce that now. 10/6 reduces to, oh, what just happened there? Erased too much. Okay, just erased too much, okay. Let me just rewrite this then. I lost track of where I was just a moment. So here we are. Okay, 10/6 can be reduced. Negative 5/3 x. Half of 74 is 37. Half of 12 is 6. 37 is prime. I can't go any further, so this is my final answer. Okay. Okay, so one thing I haven't done is this right here. Justify each step. I've said it, but I haven't written it. You need to write it. If it ever asks you to justify steps, you have to write the steps. Okay, so what happened here was from the first step to the second, I converted to improper fractions. Then I did the distributive property. Then I rearranged, which is the commutative property of addition. And then I grouped and I added different So I didn't show my parentheses, but I could have shown parentheses around this here, showing that's what I was going to do. And whenever you move parentheses around, then that is the associative product. And then you just apply the addition to combine like terms. Exercise 3. So now it's your turn to try. Take a few moments, pause the video, see if you can do this if you haven't done it already, and then come back and check my solution. Okay, so you should have gotten these in standard form. Finding the product and collecting like terms. So the first thing I'm going to do is make this improper. 6 times 3 is 18, plus 1 is 19, so that's negative 19 over 3. Okay. And while I'm at it, I might as well just distribute as well. I'll just change colors for this step. So I'm going to distribute here and here. A negative times a positive, always do the sign first, is negative. 1/2 times 1/2 is 1/4. A negative times a positive is negative. 1/2 times y is 1/2 y. Okay. We are in the habit of making a positive a negative, plus a minus. So I'm going to do that. So if I make this plus, this in parentheses, make it a negative, do the same here, this in parentheses, and make it a negative. So it's plus a negative 1/4, plus a negative 1/2. Okay. Now I'm going to combine like terms. So I'm going to rearrange this so my variable comes first. We always want to do variables and then constants last. So I'm going to rewrite this as negative 1/2 y. All I'm doing is bringing this term out in front. And then plus a negative 19/3 plus a negative 1/4. Okay. I can't do anything with this y. It's all by itself. My final answer is going to have a negative 1/2 y. We're going to simplify these two, and that's going to be our final. So now I have to add these. I have to have like denominators. So it's going to be plus a negative, and I need a 12 denominator, so I have to multiply by 4. 19 times 4 is 76. Plus, and I need a 12 down here, and I had to multiply by 3, so 3 times 4 is 3. So I have negative 1/2 y, and then just add these. Plus, negative 76 plus a negative, forgot my negative here, negative 3 is a negative 79. 12. Okay. I can still simplify this, so let's bring this up. Negative 1/2 y plus, and then I just simply have to say 12 goes into 79 6 times. With a remainder of 7. Okay. And then once we're finally done, we don't want to have a plus and minus in our problem, so the final answer is going to be negative 1/2 y plus a negative means minus 6 and 7 twice. Okay, some of these can get a little complex, but it's not too bad if you take your time and do one step at a time. Okay, 2/3, 1/3, 1/4, 1 1/3. So we only have one improper fraction. So I'm going to just rewrite all of these. Three times 1 plus 1. Okay, so now I just made that improper. Okay, now I'm going to distribute. So now I need to distribute this 1/3 here and here. So I'm going to get 2/3 stays just as is. Remember the signs first. Positive times a positive is positive. 1 times 1 is 1. 3 times 4 is 12. F. Positive times a negative is a negative. Okay, or if you wish, plus a minus. 1 times 4 is 4. 3 times 3 is. Okay, so now I have a constant here and a constant here with a function or a value that has an f variable that's all by itself. So I'm going to write the variable first. So my answer is going to be 1/12 f plus something or minus whatever sign is. I'm going to rearrange this and put 2/3 next. All I did was move this here and that there and bring up the plus and negative 4. Okay, in order to add like terms, fractions, the denominators have to be alike. So I'm bringing down my 1/12 f, and I need a common denominator of 9. 3 will go into 9, 9 goes into 9, so this does not change. 3 times 3 is 9, so 3 times 2 is 6. So 2/3 is the same as 6 ninths. Okay, so now I'm going to bring this up here. I ran out of room. 1/12 f plus 6 ninths plus a negative 4 ninths. 6 minus 4 is 2 ninths. And that is my answer. Okay. Example 4. Model how to write the expression in standard form using rules of rational numbers. Okay. We're going to do this 2 different ways. First thing I'm going to do, I'm looking at this and I see plus, plus, plus. We are adding 4 fractions, and they look pretty scary at the moment because there's all kinds of different numbers in the denominator, and we've got variables with x, and this just looks like a real complex problem, but just like anything else, you do it in pieces and before you know what you're doing. I always say this in class: if you play a musical instrument, you don't look at the entire sheet of music and say, I can't play that. You play one measure at a time, one note at a time. That's what we're going to do here. So I have a 20, I have a 5, I have a 2, and I have a 10. They're even. They're all even, except for the 5. But 20, 5 will go into 20 4 times, 20 will go into 20 10 times, and 10 will go into 20 twice. So our least common denominator is going to be 20. So x plus 20 will not change. But I need a 20 here. So in order to get a 20 from 5, I had to multiply top and bottom by 4. So 4 times 2x is 8x. Okay? Plus, I'll change the colors here for this one. I need to multiply 2 by 10 to get 20 in the denominator. And I need to multiply the top by 10, but I have to be careful and distribute. So 10 times x is 10x. 10 times 1 is 10. So it's 10x plus 10. Just distributed here and here. Okay? And then finally, we're going to do the last one. I need to multiply 10 by 2. I also need to multiply 3x plus 1 by 2. And I need to distribute that as well. So 10 times 2 is 20. So I have my 20, 20, 20. Okay? 2 times 3x is 6x. Minus 2 times 1, 2. Okay. So I have x over 20 plus 8 over 20. 8x over 20 plus 10x plus 10 over 20 plus 6x minus 20 over 20. Okay, well, we have a rule in math that if we are adding fractions and the denominators are the same, for example, if I have 3/8 and I add 1/8 to it, I can have 3 plus 1 over 8, which is 4/8. Okay, 3/8 plus 1/8 is 4/8, so I can represent it as the numerator added all up. So we can do the same here with only one denominator at a time. So in other words, what I'm saying is I'm going to take these 4 fractions and make one fraction out of them by combining all of these terms up top. So I'm going to add x, 8x, 10x, and 6x. Those are my like terms. x plus 8x is 9x. 9x plus 10 is 19x. 19x plus 6x is 25x. I'm going to do the same with my constants. I have a 10, and I have a negative 2. 10 minus 2 is positive 8. Okay, so this just really got simplified down to 25x plus 8 over 20. Okay, now that I've done that, I can split these up and put 20 underneath both pieces and say 25x over 20 plus 8. Okay, and then I'm going to reduce those. 20. 5 will go into 25 and 5. 5 will go into 24 times. 5 will go into 25 5 times. It's 5x over 4 plus 4 over 10. What will go into 8 and 20? And the answer is 4. So 4 will go into 8 twice. 4 will go into 20 5 times. So I get 5x over 4 plus 2/5. Okay. All of this mess got simplified down to just these two terms. Okay. The other way I can do it is I can take the x's, take the fraction out in front of the x. So think of this as 1x over 20, and I can rewrite that as 1 over 20. Just put the x out in front of this. So x over 20 is the same as 1/20th of x. Plus, take this 2 over 5 out in front, and put the x after it. And then I have an x plus 1 over 2. Okay, so I can put the x over 2, okay, plus the 1 over 2. So that's x over 2, or 1/2 x, let me rewrite it as that, plus, so think of that as a 1/2 x, so it's 1/2 x, x over 2, half of an x, plus 1 over 2. And then this 3x over 10 would be 3 over 10x, and then minus 1 over 10. Okay? Now this looks a little bit messier because we spread it all out and got all the x's out of it. But now what we can do is put the x's together. And I'm going to do the distributive property backwards, so I'm going to factor out an x. So notice that I have an x here, and here, and here, and here. So I'm going to take the coefficients from that. Remember the term, the number that you multiply and a variable by is called a coefficient. I'm going to take the coefficients, and I'm going to put them in parentheses. 1 over 20 plus 2 over 5 plus 1/2 plus 3/10. And I'm going to put an x after all of that because that's the distributive property backwards, which is called factoring. Okay? And then I've got to focus on the 2 that are left over that don't have an x, and those are going to be together at the end. So it's going to be plus 1/2 minus 1/10. Okay, so I combined everything that had an x and everything that didn't. Okay, now I'm going to get like terms. 1 over 20 plus, if I have a 20 here, I multiplied it by 4, plus, if I have a 20 here, I multiplied it by 10. Okay, plus, if I had a 20 here, I had to multiply it by 2, which is 6. Okay? And then it's plus, and common denominator for this would be 10. So, let's see. If I wanted 10 in the denominator here, I'd multiply 2 by 5, so it's 5/10 minus 1. Okay, so now let's simplify our like terms. 1/20th plus 8/20ths. 1 plus 8 is 9, plus 10 is 19, plus 6 is 25. So I get 25/20ths x, okay, plus 5 minus 1, which is 4/10. Okay, and then when I finally reduce it, I get 5 over 4 x plus 2/5. Okay, so I got the same answer either way. Okay, on this page it's telling us to evaluate the original expression, which I have brought in right here, and then the answer we got, and to see if there's true. So we want to plug in x equals 20. So if I do that, I'm going to have 20 over 20 plus 2 times 20 over 5 plus 20 plus 1 over 2 plus 3 times 20 minus 1 over 10. Okay, so I just put the 20 in for all these x's. Over here it's going to be 5 times 20 over 4 plus 2 over 5. 20 over 20 is 1 plus 40 over 5. Okay. Actually, let's leave this 20 over 20 because we have fractions that we're going to have to find a common denominator. So I'll just leave that as fraction. And this is going to be 40/5 plus 21/2 plus 60 minus 1 is 59/10. Okay. All right, so I've got common denominator 20. So 20 over 20 doesn't change. Plus, this has to be a 20 and I had to multiply it by 4. That'll give me 160. Plus, this has to be a 20, so I multiplied by 10, which is 21 times 10 is 210. Plus 20 here, I had to multiply by 2. 59 times 2 is 118. Okay. If I did my math correctly, 59, 5 times 2, 60 times 2 is 120 minus 2, yes. Okay. So now I'm going to combine all of these and get 160 plus 20 is 180, plus 210 is 390, 490, 508. 508 over 20, which equals 20 will go into 50 2 times, which is remainder 10, or 10, yes, and 20 will go into 108 5 times, the remainder of 8, which is 8 over 20, which reduces to 2/5. 25 2/5. Okay, I sped that up a little bit. I did mental math. Okay, I'm not going to spend a whole lot of time explaining multiplication at this point. Okay, and this one here, 5 times 20 is 100 over 4 plus 2 over 5. Common denominator for 5 and 4 is 20. I had to multiply this by 5, so 5 times 100 is 5. I had to multiply the 5 by 4 to get 20. So 4 times 2 is 8. So as you can see, I got 508 over 20, which I got here, and that equals 25. Okay, so that's how we check our work when we're done. Plug in a given value to the original, plug in a given value to what we got, and if the answers are not the same, then we did something. Okay, exercise 4 says to rewrite the following expression in standard form by finding common denominators and collecting like terms. So I have a 3, I have a 9, I have a 6. 3 goes into 9, but 6 won't. So then we go on to the next one. 9 times 2 is 18, and 6 times 3 is 18, so there's our common denominator. So step 1, I'm going to put everything over 18. So 3 times 6 is 18, and 6 times 2 is 12. I'm going to put h out front this time, like this. Okay, I can do that, or I can leave it up in the numerator, but I think I'll just do this here. Okay, and then the next one is minus, and then we're going to have 18 in the denominator. 9 times 2 is 18, so 2 times h is 2, and then I can put the h over here as well. And then plus, and 18 again. 6 times 3 is 18, so 3 times h is 3h. So I'm going to put a 3 here and an h here, and then minus 4 times 3, which is 12. So in this case, I can't bring this down, so that would not work if I did that. So I'm going to just do 3h minus 12. I would have to split that up and do 18 over the whole thing, okay? All right. Now, once I look at this, there's an h in every term. So I'm going to change my mind here, and oftentimes we don't see it until we're done. Instead of doing this 12 and the h out in front like that, I can actually put the 12h in the numerator, put the h as a whole number up in the numerator. Okay, so I'm going to try that, and then if I move this 2 and the h out of the way, and just bring the h up into the numerator instead of out here, then I see I have h's in all of these, so I can combine them. So 12h minus 2h. So I'm just going to rewrite this for the first time. I'm writing all of the numerator as one numerator, all over one denominator of the 18. Once they're all the same, I can do this. So 12h minus 2h is 10h plus 3h is 13h minus 12 over 18. Okay, now I can split the 18 back up and say it's 13 over 18h minus 12 over 18. And that comes out to be 13 over 18h minus 2/3. Okay, and that's the final answer. Actually, I went up too high with that square. Here's my answer. All right. Example 5. Rewrite the following expression in standard form. Okay, so we're going to do this in a few different ways just to show you that each method will come up with the same answer. And the first thing I'm going to do is I'm going to reduce. So 2 will make the 6 a 3 and the 2 a 1. So it's going to just be 3x minus 4 because I canceled the 2 and the 6, and the 6 became a 3. Okay. Minus 5x plus 2 over 8. Can't do anything with that. So now I see that I have 8 and a 3. So usually when we only have two numbers and one won't go into the other, we just multiply the two and our common denominator will be that number. 8 times 3 is 24. So I can multiply this one by 8, multiply this one by 3. So I get 24 and 24. Okay, so when I do that, 8 times 3x is 24x. Positive times a negative is negative. 8 times 4 is 32. Over, and I'm multiplying by 8 over 8, by the way. 3 over 3, so that's 1. 8 times 3 equals 24. Minus 3 times 5x is 15x. 3 times 2 is 6. Over 24. So then I take my like terms and I can combine these, and I can rewrite this as 24x minus 15x minus 32 plus 6. So I'm just combining my x's and my minus 32's, putting them all in one numerator over 1, 24. Okay. And I need to be careful here because a minus 15x is minus 15x, but a minus 6x, that should be a minus 6x right here. Okay, so I need to change that to minus. Okay, so it's 32, negative 32 minus 6. Okay, so be careful with your signs. I just glancing back up and pop. Now 24x minus 15x is 9x. Minus 32 minus 6 is minus 38. All over 20. Okay, now I'm going to separate these. Put the first term over 24. Put that minus sign in between. Take the second term, 38. Put that over 24. Okay, and then finally reduce. 9 will not go into 24, but 3 will. 3 goes into 9 3 times. 3 goes into 24 8 times, and these are even, so divide them by 2, and it's 3x over 8 minus 19 twelfths. Another way to write this would be 3/8x minus 19. Okay. So when I do that, okay, so that's how to do it, method 1. And method 2, let me start over again here, change color. And then they have what they call method 2A and method 2B. Okay, so let me draw one. Split this up. Alright, my pad's not big enough to go from top to bottom, so that's what I have to do. So let's just do this. Just wanted to separate that so I can not confuse the two colors. Alright. Okay, so the first thing I'm going to do, one method, in solving this here, is to multiply, just one second. Okay, what we're going to do here is distribute. So we're going to get 6x minus 24 over 6 I'm sorry, that's 8. 2 times 4 is 8. 6x minus 8 over 6 minus 5x plus 2 over 8. Okay, so there's two methods to do this after we get rid of the distribution problem. Okay, so now we're just focusing on this problem here in blue, and I'll do one side over here, and then a different way over here. Okay, so the first thing I want to do is multiply the first one by 4, and multiply the second one by 3. So the common denominator is 24. So if I take 4 times 6x minus 8 over 4 times 6, which is 24, subtract 4 times 5x plus 2 over, or not 4, 3, minus, and then I need a 24 over here, so I have to multiply it by 3. 8 times 3 is 24. So I'm going to put a 3 out here, 5x plus 2. Multiplying by 3 over 3 because that's 1. Okay. Now when I distribute, I get 24x. Positive times a negative is negative. 4 times 8 is 32. Minus 3 times 5x is 15x. 3 times 2 is minus, that's a minus. Negative times a positive is negative 6. This is all over 124, just like we did over here. And notice right here, we're at the same position right here. These are okay. When I combine the x's, 24x minus 15x is 9x. Negative 32 minus 6 is negative 38 over 24. And then we're just doing what we did in the column to our left. Okay, and then finally we get 3/8 x minus 19 plus. Okay. Okay, now let's do this in a different way now. And the first thing I'm going to do is I can split all of these up. These are just showing you multiple methods to do the same type of problem. So 6x over 6 minus 8 over 6. Okay, so I'm just putting this 8 over the 6 minus 5x over 8 minus, because a negative times a positive is negative, 2 over 8. Okay, so all I did here was split up both of these fractions. Okay, now I'm going to rearrange these, put the x's together. So I'm going to take 6x over 6 minus 5x over 8 minus 8 over 6 minus 2 over 8. Okay, so I just put the x's next to each other and the constants. Okay, so this is 1x. Think of that as just 6 over 6 is 1, so that's just 1x. And 1x minus 5/8, well, 8/8 is another way to say 1. 8/8 minus 5/8 is 3/8x. And then I need to make these common denominators. So I can reduce this. 8/6 is 4/3. And 2/8 is 1/4. Okay? So the first thing I'd like to do is reduce them so I don't have to use such a large number. Now I can find the common denominator for 3 and 4, and that's 12. So now I have 3/8x minus 2 fractions with a denominator of 12, and I had to multiply the top by 4, and 4 times 4 is 16. I multiply this one by 3 over 3, so 1 times 3 is 3. So now I finally get 3/8x minus 16 minus 3 is 13 over 12. Okay? Oh, not 13, I'm sorry. So this is 3/8x minus, so this is a minus and then minus some more. So negative 16 minus 3 is negative 19 over 12. Okay. All right, so there is the answer. So notice we've done this 3 different ways now. We've got 3 different answers. And now there's going to be another method. Finally, I'll do this last one here. And let's see, what was the original? Let's back up. Let's erase our arrow here. Okay, so I'm going to reduce this 2/6 right off the bat and call it 1/3. So I'm going to start with 1/3. And then I'm going to put numerator 3x minus 4 next to 1/3. So what I'm doing is taking this 2/6, I'm sliding it out front and then reducing it. Okay? And then once I do that, I can't do that with this one here because it's not in parentheses. This one was in parentheses. The 2 is out by itself. This 5 is not out by itself. I can't take a 5 out of a 2, so I can't do anything with that. So I'm just going to write minus 5x or 5/8x. I'm going to write it like this, plus 2/8. And actually it's minus because it's a minus a positive, which is minus. Okay, so it's going to be 5/8x minus 2/8. Okay, be really careful with your signs. Minus positive is negative. Minus a positive is negative. So negative 5/8x minus 2. Okay. Now that I do this, I distribute, and 1/3 times 3 is just simply x, and 1/3 times 4 is a minus 4/3, minus 5/8x minus 1/4. I just reduced 2/8. So x, now I'm going to rewrite this as x and minus 5/8x. So I'm just moving this over here, minus 4/3 minus 1/4. So I just move these to rearrange a commutative property of addition. Okay. On 1x minus 5/8, now 1 can be represented as any number divided by itself, so that's the same as 8/8x. So 8/8 minus 5/8 is 3/8x minus, and now we need our common denominators again. And I have to multiply this by 4, so I get 16 in the numerator multiply this by 3 to get 12, so 3 times 1 is 3. I finally get 3/8x minus 16 minus 3, which is 19 over 12. And as you can see, all 4 answers are correct. Multiple ways to do the same type of problems. Okay, one more and this video is finally done. I know it's lengthy, but this is an important concept. The more you practice, the better it is. Okay, so there's multiple ways to do this. You can do it many ways. You can bring this 3/10 out. You can distribute all sorts of different things. We cannot take this 2 and 4 out because of this 11. Okay, that's another way of, that's why we did this multiple methods up here. To show you that you can take a number being multiplied and reduce, but you can't take a number that's being added and reduce. We could not do that. Okay, so that's the same scenario here. I could bring this 3/10 outside and make just x minus 2 helps after the 3/10, but I can't do that with 2 4s because the 4 is attached to the 11 without a parenthesis. Okay, so what I'm going to do is I want to get common denominator, and it's going to be 20. 4 will go into 25 times. So this time I'm going to show what I'm doing. Multiplying the left by 5 over 5, which is 1. Multiplying the right by 2 over 2. Okay? That's what I want to do. But then I get thinking about this, and this might confuse people because we have a 3 times an x minus 2 times a 2. And if we distribute first, it might be less confusing. So let's do that first. So these are different things that go through your mind when you try to figure out how to do something. So I'm going to do the distribution first. I'm going to do this step here first, and then I'll do what I was explaining. I'll start over here. So I have 2x minus 11 over 4 minus 3 times x minus 3 times a negative 2 is a positive 6 over 10. Okay? So if I get rid of those parentheses, you got to watch that sign. That's a negative 3 times a positive x, which gives us a negative 3 x, and a negative 3 times a negative 2 is a plus 6. So the signs change with period of parentheses. Okay. Now I'm going to multiply each to get a common denominator. So I multiply this by 5 over 5, and I multiply this by 2 over 2. So now I'm going to distribute again. So I'm going to do this. And 5 times 2x is 10x. 5 times 11 is minus 55. Over 5 times 4, which is 20. Minus 2 times 3x, which is 6x. 2 times 6, which is 12. Over 10 times 2, which is 20. Now that I have the same denominator, I can just rewrite this whole thing as one fraction. I'm going to put my x's first. So I'm going to say 10x minus 6x minus 55 plus or minus a positive 12, which is minus 12. All over 20. Be careful with your signs. So now I can combine my like terms, which is here. 10x minus 6x is 4x. And negative 55 minus 12 is negative 67. Minus 67 over 20. Okay? Now I can take that 20 and distribute it among each numerator piece. This is how they binomial. And I can rewrite this as 4x over 20 minus 67 over 20. And this will reduce to 4 goes into 4 once. So I'm dividing it by 4 over 4. 4 goes into 4 once, just leaving x. And 4 goes into 20 5 times. So that's like 1/5 x, or x over 5, minus 67 over 20. Okay, if I don't want this to be a improper fraction, I'll do 1/5 x minus 20 goes into 60. 3 times the remainder of 7. Okay. And there's my answer. Oh, what happened to my... That is not my answer. 1/5 x, 20 goes and 7/20ths. Okay, I think I erased that by mistake. Okay. There's my answer. 1/5 x minus 3 7/20. Okay, now looking back, I noticed I did something here. So 10x minus 6x is fine. Minus 55 minus a 12 right here. I've already accounted for the minus to make it plus, so this should actually be a plus 12. I made a mistake right there. It should be plus 12. So instead of 67, we had to add 12 back and then add 12 again. So negative 55 plus 12 is negative 43. And that will change this answer right here. Okay, just the last piece was wrong. So it's negative 20 will go into 43 2 times the remainder of 3. Okay. Sorry about that, but it's always good to check when you're done. That's the end of a very long lesson, lesson 6. Now go do your problem set.